All right, now we need to determine the equation of the image of y equals x squared after a reflection in the line y equals negative x. Okay, so now we're going to have a mediator line which is y equals negative x. So before we even start, let's just imagine what's going to happen. Okay, we have our points 1, 0 and 0, 1. And the line y equals negative x is that line over there. So if I'm reflecting my points, my point 0, 1, let's do it in red, moves to over here and becomes negative 1, 0. And my point 1, 0 is over here and that becomes 0, negative 1. So that means that 1, 0, 0, 1 becomes 0, negative 1 and negative 1, 0. So you don't need to necessarily write that down as such, but it does help you to get a picture of what's happening with this reflection and with this transformation matrix. All right, so what we've got is we've got a mediator line or a transformation matrix, a reflection matrix about y equals negative x, and we have established that this thing looks like this. It's 0, negative 1, and 0. We also know that our original points on our original function will be x and y, and our image function, our p prime, will be x primed and y primed. Now, remember that with a linear transformation, we've got matrix multiplication. So the first thing we're going to say is that our transformation, our p primed, is t times by p. Now remember, with our translation, we were using matrix addition, and we rearranged it so that we could get our original points in terms of our translation points, so that we could find our new function and then work with it. We're going to do the same thing with linear transformations. However, we need to use inverse matrices because we have matrix multiplication. Okay, so the second thing we're going to do is we're going to show our steps of our matrix algebra, and that's going to involve multiplying by our inverse matrix on both sides. And remember that order matters, so we're multiplying on the left hand side here, and inverse tt is just I, so we've got t inverse p primed, and so therefore our original matrix was inverse t and p primed. All right, now we're going to actually show that work. So we're going to say, well, xy is equal to our inverse of our transformation matrix multiplied by x primed, y primed. And we know how to find an inverse. Now you can do this all in one, or you could do it to one side, but we know that our inverse of t is 1 over our determinant, so our AD minus BC, so it's going to be 0 minus -1 times -1, and then we're going to swap our A and our D and the signs of our B and C, and we've got x primed, y primed, and so xy is going to be 1 over -1. Okay, so we get -1 multiplied by 0, 1, 0, 1, 0. So we've got 0, negative 1, negative 1, 0, x primed, y primed. And when I perform my matrix multiplication, I've got a 2 by 2 and a 2 by 1, so I'm going to end up with a 2 by 1, and I'm going to get negative y primed, negative x primed. And very similarly to what we did with our translation matrices, we're now going to create two equations that we're going to use simultaneous equations for. So I can say, therefore, x is equal to negative y primed, and y is equal to negative x primed. And that's equation 1, and that's equation 2. All right, our next step is we're going to substitute those into our original function. Okay, so our next step is we're going to substitute equation 1 and equation 2 into y equals x squared. And so we have negative x primed is equal to negative y primed squared. So negative x primed is equal to y primed squared. So I can rearrange that so that it becomes y primed is equal to plus or minus the square root of negative x primed. And hopefully you recognize that as a sideways parabola. And then we're going to say, therefore, our image equation is, and we get rid of our primes. Y is plus or minus the square root of negative x. All right. Now, what's important about this is that this thing is actually only going to be valid. Have a look at the value of x there, where x is a negative number, because we can't find a square root of a negative number. So it is important that we put a domain in for this function. Very important. Don't forget to add your domain. All right, let's have a quick look at what this thing looks like. They wanted us to sketch the original and the image curve. So if we have our original y equals x squared, which we know is a beautiful curve looking like that. And it's now automatically done that for me, so I'm just going to make it, I'm not going to, there we go, that will do for y equals x squared. And we know what our sideways parabola would look like if it had a negative a and b value. So here's our line y equals negative x that we're reflecting about, and our function looks something like that, and that's our y equals negative x, and this is y is plus or minus the root of negative x. And we're then going to say, therefore, the solution is verified as the curve is reflected about y equals negative x.